Okay, good morning, everyone. Okay, welcome back to our economics class. And yesterday we started a new lesson here, right? What is the name of the lesson? Measures of central tendency. Measures of a central tendency. Basically, that lesson is related with the mathematical calculations to find out the averages, mean, median, mode. Okay, so number of mathematical calculations are needed here. Yesterday, I give a homework for you people. Only 5 people submitted the answers. Submitted the answers. Others, what happened to you people? No idea. Okay, so remember, within short time, we will meet in person. Clear? Okay, so just to keep that idea in your mind. Okay, every day I am recording that the people, those who are completing the homeworks, completing the assignments, and complete the tasks in time. In time. Okay, same time. Okay, others are considering as the people those who not complete the task. Clear. So just keep that in your mind. This is not that kind of what we can say Himalayan task. Simple activities. Easily you can complete that, but not doing that. What's the trouble with you guys? What's the trouble? Huh? What happened? Ashish Binni, Karthik, Amal Raj. Amal Raj submitted that? No.
Sir, I have submitted.
Yeah, Karthik. Yeah, right. Okay. So the problem with you guys, there's no idea about that. Huh? You're busy with some other activities. How many periods are there regularly? Maximum 5 to 6, right? Nothing more than that. Nothing more than that. Then one simple calculation, you are unable to do that and unable to present that in time. Present that in time. Okay, so remember, there's a program is this time that's do or die. Okay, do the work or die. That's it. Clear or not? That's the policy by Mahatma Gandhi, basically. He used it in another way. What is that? Do or die. Okay, do something for independence or you go and die. That's what the procedure. That's what the comment that made by Mahatma Gandhi. My comment is nothing, something different. Do it or die. Ready to die. That's all. Okay, not now anyway. We will meet within short time. Okay, so just to keep that in your mind. Clear. So that is a simple work. The same within 1 minute we are able to complete that. Okay. Anyway, moving forward. So the people listen carefully. Okay, everyone listen carefully. Okay, so don't think that you're sitting in a home. No one is there to giving backup or following the procedures there. Don't think like that. Don't think like that. So I already told you that the two proverb for you. Now it's a proverb basically that is the comments that made by Swami Vivekananda. Swami Vivekananda. What are they? What are they? Any idea? Anyone remembering that? Anyone remembering that? What is that? All powers are within you. You can do anything and everything. What is that? All powers are within you. You can do anything and everything. Anything and everything. Okay. Contradictory to that same statement, one other statement made by the same person, Swami Vivekananda. What is that? You are the creator of your own destiny. Clear? Clear. Okay. Hope that ideas are clear. All right. Okay. All powers are within you. You can do anything and everything. The same time. Okay. This is not a philosophy class. This is a economics class. I know that. Anyway, just keep these ideas in your mind. What is that? All powers are within you. You can do anything and everything. The same time, you are the creator of your own destiny. You are the creator of your own destiny. Okay. So escaping from the philosophy, we are moving to economics. Okay, so yesterday we discussed the one method to find out arithmetic mean, right? Okay, the most common methods, most common method. What is that? Sum of x divided by the n. Sum of x divided by n. Simple method, calculating or adding all these single digits together and dividing that with the total number. Total number. Sum of x divided by n. That's what the simplest method we used to find out the arithmetic mean yesterday. Arithmetic mean yesterday. And today we are moving forward with some more complicated ideas. Okay, the ideas are complicated, but the answer is same only. No differences. Okay, so just understand here. So we completed this method of arithmetic mean from page number 59 and moving forward with the page number 60 and we are here 56.2 this answer for a question. That's the direct method to find out the arithmetic mean. We converted first of all we find that the sum and divide that with the number. We have got the answer, which is 56.6. Okay, next one. Assumed mean method. Assumed mean method. Another one method. Okay. Here, if the number of observations in the data is more and or figures are large. Okay, the figures are large or the number of observations are large or more. Okay, it is difficult to compute arithmetic mean by direct method. Okay, number of data are there and the data are too big, digits are too big. It is impossible to find out the arithmetic mean by the direct method. So that time we want to use a different method. The computation can be made easier by using assumed mean method. So we are using another method to find out the answer. Basically termed as the assumed mean method. Assumed mean method. Okay. So in order to save time in calculating mean from data set containing a large number of observations as well as large numerical figures, we are using this method. Okay. So that time we can use assumed mean method. So question it is, what is that? At what circumstances we are using the assumed mean method to find out the average? Find out the average. So this is the answer. What is that? In order to save time in calculating mean from a set or from a data set containing a large number of observations, as well as large numerical figures, we can use assumed mean method to find out the answer. Okay, here we are assuming a particular figure in the data as the arithmetic mean on the basis of logic and experience. Okay, so easily we are able to find out the arithmetic mean with the direct method with the logic and experience. And here also we want to use the same. Then you may take deviations of the set assumed mean from each of the observation. You can then take the summation of these deviations and divide it by the number of observations in the data. So now for this method, we want to find out the differences between the data. Okay, the actual arithmetic mean is estimated by taking the sum of the assumed mean. Okay, so it is a assumed mean and the ratio of sum of deviations. Okay, to number of observation. Symbolically we can do the thing like this, right? This is the method. With the logic we are able to find this up, and now we are going to find out the arithmetic mean directly using as particular methods. Okay, here there are a number of notations are there for you people. I know that you already learned this method. Okay, yeah, so we know that A is the assumed mean here. A is the assumed mean here. Okay, this is assumed mean method. Okay, Muhammad Irfan, please mute your mic. Muhammad Irfan. Okay. So A is the assumed mean. Next one, X, individual observations. And N here, total number of observations. N is the total number of observations. Clear? And the D is a deviation of assumed mean from individual observation. So D is always X minus A. X we know that individual observation. A is the assumed mean. Okay, with experience we are able to take that. Here the sum of all deviation is taken as a sum of d. Okay, sum of d that is equal to sum of x minus a, individual observations minus the assumed mean. Okay, sum of individual observations okay, minus the assumed mean. Okay, here then sum of all deviation is taken as a sum of d is equal to sum of x minus a. Then find, we are able to, so now we want to find out sum of d divided by n. Then add a, I mean assumed mean should be add there. Okay, then we will get, then add a and sum of d divided by n to get the arithmetic mean. Therefore the equation is like this. Okay, x bar arithmetic mean is equal to a plus assumed mean plus sum of d divided by n. That is the equation here for you people to find out the assumed mean. In which condition we are using this technique? If the data are more in number or numerical digits are too large or high. Okay, in that method we are using, sorry, in that situation we are using this assumed mean method instead of direct method. Instead of a direct method. Okay, here you should remember that any value, whether existing in the data or not, can be taken as assumed mean. So we are able to take any data as assumed mean. Okay, that is existing in the data list or not, that's not a problem. Okay, that can be taken as an assumed mean. However, in order to simplify the calculation, centrally located value in the data can be selected as assumed mean. Okay, so a central data we are using as the assumed mean here, assumed mean for the calculation that follows. Okay, a central value. Any number we are able to use as an assumed mean. As per our assumption, we can take a particular number as assumed mean. Okay, but for easy calculation, we are using the central value, almost the central value here. Okay, here the following data show the weekly income of 10 families. What are the families here? 10 families are here. Okay, what are they? Family number A, family number B, family number C, D, E, F, G, H, I, and J. 10 are there, 10 families are there. So their weekly income, okay. So income of A, it is 850, 850. Income of B, that is 700, 700. C, 100 rupees. D, 750, 750. Okay. Next one, E 5,000. F just rupees 80. G 420. Okay. H that is 2,500. I rupees 400. Okay. And J it is rupees 360. 360. So the direct method, what we will do, we will add all these things together and we will divide that with the number of families. How many are there? 10 are there, right? So it's an easy method, right? Okay, but here is the problem. Some digits are too high, and here 10 are there. Number is 10. 10 families are there. Okay, a larger data. So we are going to use this method. Which method? Assumed mean method. Assumed mean method. Okay, so now we are going to take an assumed mean as per this example. It is 850. 850. Okay, 850. Clear or not? So that is considering as a central value here. Less than that, 850, 1, 2, 3, 4, 5 are there. Okay, 5, 6 are there. More than the 850, okay. Okay, one more is there, 750 also less than 850 only. Okay, more than that here, 5,000 is there, 2,500 is there. Okay, two datas only, two datas only. Okay, so no problem, we are able to take that number. And we already know that any number we are able to take or the number that comes the almost the central tendency, tendency also we are able to see here. Okay, clear. So families is written here. So it's we have created a table here. Okay. So families are there. That is A to J, A to J. Okay. 10 families are there. And corresponding income of the family we wrote there. That is 850, 700, 100, 750, 5,080, 420, 2,500, 400, 360. So all together, after calculating or us adding all these income of different families, we got a number here. What is that? 11,160. Okay, please check this calculation is correct or not. 11,160, is that correct? Is that correct? Check it fast. Correct? Okay. So that first step completed. Okay, then just divide that with 10. What the answer will be there? What answer you will get? What answer you will get? You will get 1116, right? In direct method, answer is there. Answer is there, right? Right? Yes or no? This 10 will, the 0 will cancel. If you are dividing that with a 10, the 0 will cancel there. So we got rupees 1116. 116. Okay. But in this method, we want to use one particular step here. What is that? What is the step here? Okay. The first step, we want to find out the deviation of assumed mean from the individual observations. So we took a assumed mean as 850. So 850 is the A here. Assumed mean is 850. And we want to minus that 850 from the income of different families there. So first family 850. So 850 minus, sorry, here it is. 850. So 850 minus 850. What we got? 0. Right. So we wrote 0 here. Next digit is 700. Okay. Next one. 850. Okay. You can see here. Okay. 700 minus 850. So we got a negative 150. Minus 150. Minus 150. Clear or not? Coming to 100, we will get a minus 750. Minus 750. Next one, coming to 750, we'll get a minus 100 here, minus 100. Hope you are able to see the screen properly. Okay, the screen is visible. Want to increase or reduce the size of the screen? Tell me. Hello, can you hear me?
No need, sir.
No need. It's okay, right. Okay, so that's what. Coming to 5,000, we'll get it is a big figure, 4,150. Okay, it is a positive sign. Next one, a positive number it is. Next one, coming to 80, we will get that is 80 minus 850. 80 minus 850, so you got 770. 770 negative minus 770. Next one coming to the next digit 420, that we go to 430 minus 430. Next to 2500 we got plus 1650. Coming to 400, the income of J, that is minus 450, and here it is I. Next one is J, that is 360. So 360 minus 850, you got minus 490. Minus 490. Okay, so that's it. Clear or not? Next activity, we want to find the D dash. Clear? Okay, so the difference between, or so we want to divide these differences or deviation by the number of families. So in the first, here it is. The first we got a family A, 850 minus 850, we got 0. So 0 divided by 10, you know that it is 0, no value. Okay, leave it. Again, next one B, we got 150 here. 150 divided by 10, that is a negative, minus 15. Coming to 750, minus 750 divided by 10, we go to minus 75. Minus 75. The equation is here. Okay, x minus 850 divided by 10. That's what the D dash here. D dash. Okay, the changes we are able to find here. Okay. Okay, the real number we converted that into smaller digits here, by dividing that with the total number of families. Coming to 100 divided by 10, minus 100 divided by 10, that is minus 10. Okay, 4,150 divided by 10, again we go to plus 450. Okay, like that, number of data. We arranged another set of data here. We created another set of data. Okay, this is the first set. The families, their income, and the third set, that is what is the assumed mean method. We created another set of data and divided that with the number of families. Second set of data also created. So first set of data created, and this is second set of data created, and these data are already in the question. Already is there in the question. Okay. And by adding all these, the first set of data that what we created by reducing the assumed mean from the real income, okay, we got the answer 2660. Okay, a number don't have a relation with the income of the family here, right? No relation at all. Okay, we got a new number here. Okay, then another one by dividing with the 10, we got another number. Or if we are adding all these numbers also, we will get the same. Okay, because we already divided that with the 10 here. Okay, so we got a plus 266. Okay, clear. And we are going to apply this numbers in this equation. What is that? X bar is equal to a plus sum of d divided by n Okay, so what is that? What is the assumed mean here? So assumed mean here, that is 850 plus sum of d. This is the d here. The first set of data that what we created, that is a d here. So we used that data here, 2660. Okay, divided by n. What is the number here? 10 is the number. 10 is the number. So what is the answer? What is the answer? Okay, in direct method also we got the same answer, right? 116. Okay, so a simple method. Okay, so we converted that into a complicated one, right? Okay, because the number of data are high or the values are high, we are using this method. You are using this method. Okay, now there's a simple calculation for you people. Okay, just with 5 digits, 5 families I will give now. Okay, so I write down family A, B, C, D, E. 5 families are here. Okay, and their income it is 150, 200, 175. Okay, then 100, again 500. Okay. Okay, so this is homework for you people. Homework number 1. Write down. Okay, find out the, what is the question? Find out the assumed, find out the arithmetic mean by using a assumed mean method. Okay, assumed mean method. First question. Okay, second question. Here A, B, C, D, E, F, G, H, I, J. Again 10 are there. 800, 700, 150, 350, 425, 750. Okay, 2000, 1200, rupees 20, J, 1000. Question number 2, homework. Question number 2, A is 800, B is 700, C is 150. Okay, D is 350. D is 350. E is 425, F is 750, G is 2000, H is 1200, I is 20, and J is 1000. J is 1000. Same question only. Find out the mean by assumed mean method. Okay, assumed mean method. Okay, coming to the third question. Okay, family 1, family 2, family 3, 4, 5, 6 individuals are there. Their income 50.1, 75.2, 80.5, 60.1, 75.2. Okay, and 80. 80.3, 0.5, 0.5. Okay. Come on. So there's one more change, 80.5 and 60.2. So first family 50.1, second family 75.2, third family 80.5, fourth family 60.2, fifth family 75.5, sixth family it is 80.5, 80.5. Rot, rot or not? Okay, so three homeworks are there, not completed. Again, two more homeworks are there. I will give that by completing the next topic. Okay, don't worry. Okay, so moving forward. Okay, so with assumed mean method, we find out the answer here. Okay, the direct method also the same answer. So we came to a conclusion that both methods are okay to find out the real average or correct average. Thus, the average weekly income of the family by both methods is 1,116, and you can check this by using the direct method. We already checked that. Okay, so next method is termed as the step deviation method. Step deviation method. Okay, so in step deviation method, that's almost the same. Only we want to find all these datas. Okay, but here there's a small changes in the equation. Here we find out the d dash here. D dash is x minus the assumed mean divided by 10. Okay, so what is the equation to find out the d dash here? D dash is equal to, you can see here, x minus a divided by 10. Okay, x minus, okay, the income, independent income of the family is minus a assumed mean divided by 10, divided by 10. That's what the d dash here. That was the or that is the d dash here. So we find out the d dash already. D dash already. So next method is termed as the step deviation method. Step deviation method. In this step deviation method, the calculation can be further simplified by dividing all the deviation taken from assumed mean by the common factor c. Okay, the objective is that avoid large numerical figures. That is, if d is equal to x minus a is very large, you can see here. Okay, then find d dash. This can be done as follows. Okay, so d dash is equal to, what is that? D divided by C is equal to x minus a. C is the common factor here, 10. Okay, so x minus a divided by C. The formula is given below. X bar is equal to a plus sum of d dash divided by n into C. Okay, so where d dash is equal to x minus a divided by C, that's a common factor. Then n is equal to number of observations, a is equal to assumed mean. Okay, so thus you can calculate the arithmetic mean in the example 2 by the step deviation method. X is equal to 850 plus 266 divided by 10 into 10. So you got the same answer, 1116. 1116. Clear? Yes or no? Any difficulties there with that model? Step deviation model. You studied that earlier, right? The same way only. Okay, nothing difficult or nothing different. Okay. So that's it. Okay. So again, the fourth homework to find out the values, find out the arithmetic mean by step deviation method. Step deviation method. Okay. So the step deviation method, there are five families are there. Right. Okay. Their income is 2,500, 7,250, 9,000, 1,225, 25. Okay. Right. And 2,010 rupees and 10 rupees. Okay. So fourth question. Fourth question. What is the question? Find out the arithmetic mean by the step deviation method. Step deviation method. The equation is here. D dash is equal to D minus, sorry, D divided by C is equal to X minus A divided by C. Okay, so X bar is equal to A plus sum of D dash divided by N into C. Completed? Wrote the question? Hello,
Yes,
this,
sir.
make it fast. Completed? The question completed?
Yes, sir.
Okay. So everyone, just write down. Okay. Family one is 2,500, two is 7,250, three is 9,000, fourth family is 1,225, fifth family is 2,010. 2010. Okay. Fifth homework. Okay. Fifth homework is this. A, family A 71.20, family B 80.35, family C 75.22, family D 81.75, family E 80.15, family F 99.90, family G is 100.70, and the family H is 120.10, family I is 250.15, family J is 300.15. Any problem in the numbers? Is there any trouble in the numbers? You get it out? Okay, hope these two methods are clear for you. That is assumed mean method and step deviation method. Step deviation method. So for examination, compulsory questions will be from this part. So keep or give necessary importance for this calculations. Okay. So moving forward with the next topic. Okay, next one it is calculation of arithmetic mean for a grouped data. So that three methods, the direct method, assumed mean method, and the step deviation method that are related with ungrouped data, And we are here with the grouped data. Okay, so grouped data in the sense it is a discrete series. Different series are there, we know that. In case of a discrete series, frequency against each observation is multiplied by the value of the observation. Okay, the values so obtained are assumed up by divided by the total number of frequencies. Symbolically, we can say that x bar, the mean is equal to sum of function of x divided by sum of f. Okay, function there. Okay, where sum of function of x is equal to sum of the product of variable and frequencies, or sum of f is equal to sum of the frequencies, sum of the frequencies. Okay, so do you know this method? Or you studied or not? Can you hear me? Hello. Hello, do you know or not?
Yes.
No answers, no answers. Okay. So studied already, right? Huh? In the junior classes, remembering that. Huh? Method for group data and ungrouped data. Femina, you know that method, right? Femina, do you know this method? Yeah, then explain Femina. So this is a golden opportunity for you people. It's a what we can say. Our Femina is going to explain that. Femina, make it fast. Femina, Femina, can you hear me, Femina? I lost connection, I think. Yeah, Femina, come on. Okay, no worries. Okay, so it is almost a time up. So we will discuss in the next class. Okay, so just learn the things what you learned already in the junior classes. So it is easy to understand the things there. If you don't know, so what do you do? Take your old textbook, I mean mathematical textbook, and observe that carefully and check your old notes. Easily you are able to find that. Okay, because the notes are with you only, right? Yes or no? Yes or no? You not got any chances to sell that straight. I mean, for the scrap sellers. Okay, so the things are there with you. Okay, so just open it and learn it and understand the things properly, and we will discuss that topic in the next class. Subhampal, again, your camera is okay now? You bought a new camera? Yeah, fine. Good. Okay, okay. Everyone, thank you very much. We'll meet in the next class. Bye bye.